Back to another video dedicated to circles. If you're A-level math students, it's right for you. So you can find pretty a lot in my list related to A-level math. So there were explanations how to solve different circles problems. But today I decided to enrich this list in order to maybe clarify another way. And this is definitely the brilliant way that actually not connected with simultaneous equations, because sometimes it's hard to solve. Of course, if you have like software which allows you to do it instead of manual calculation, it's all right. So if you use GDC, that's also be relevant way how to calculate through the system of equations, and this is normally approach for the circles and lines. Okay, but I'll show you the different way. So that's why here you'll see two ways how to solve the problem, and I'll put a stress on the second way, which use trigonometry. All right, so this is the right time to know how to solve these specific problems. As you can see on the cover, you have a circle and you have actually two tangent lines which intersects and one common point. Just read carefully the problem, try to do by your own, try to apply the methods that you've been taught by your teachers. If it doesn't work, just have a look here. I'll show you alternative way, which is pretty, I think, pretty straightforward and very convenient way. If you don't have any GDCs or you don't have any online software that can resolve the system of equations, which are actually quadratic ones. Let's get started. So, alright, way one. Actually, you understand that for the lines which I mark as L1 and L2, they're both tangent lines, they have the same y-intercept, so that's why in general way we can set up equations for them. So L1 will have the following equations. So M1, which is the gradient x, plus 25 because it's y-intercept. For L2, you will have similar equation with another gradient. The main problem is to figure out the gradients. In order to figure out the gradients M1 and M2, you need to know those coordinates of those points. So let's say that generally we have, for example, let's consider L1, and let's say point D has specific coordinates x and y, okay? And this is the actually one single point that your line L1 shares with the circle. So circle has the center with coordinates a 10 and 10, and it has the radius 7.62, which is given to you to two decimal place of correctness, so of accuracy. So that's why in this case you don't have precise values, but anyway it allows you to establish the equation for the circle. So in general way, you remember that the equation of the circle is going to be x minus the coordinate x coordinate of the center, which is 10, and squared, plus the same for y minus 10 squared, and it's going to be equal to radius squared, which is 7.62 centimeters squared. All right, so I just put straightforward here. Okay, so this is an equation of the circle, and the main problem is how to figure out the coordinates of the coordinates of the points. Okay, if you use the first way. Right now I'm just gonna use the standard way how majority of students trying to solve and how they were explained definitely. So in this case we need to figure out the coordinates of point D. Let's say of point D, and everything you can repeat for line 2. So that's why for L1, in order to define the coordinates, obviously we need to put extra plotting here. So I connect with the radius, which is here. That's dA is going to be radius, and I just connect the center of the circle with the point C. So that we have triangle ACD, which is right angle with angle D to be equal 90 degrees. You know why? Because I use the theorem related to the radius, which is always perpendicular to the tangent line, which L1 is actually to be. So that's why we have right angle triangle, and we need to, or we can complete the Pythagoras theorem because it will contain points D, coordinates of the point D, X and Y. So that's why just I use basic Pythagoras for the sides. So here is the radius, which is 762. So that's why I put 762 squared. Plus, on top of that, I will add the distance between C and D. And I will use the formula for the distance. I hope you remember. So distance formula, just remind you, is square root of delta x squared plus delta y squared, where delta x and delta y is the change in corresponding coordinates between points C and D. In our case, we have for x just simply x coordinate of D, because x coordinate of C is 0, so that's why I put just simply x squared. On top of that, I will add the difference between y and 25. Doesn't matter where you're writing, whether you're writing y minus 25 or 25 minus y squared. So right now, x squared plus this is going to be a distance between 2 points C and D, all right? So that's going to be dA, and both squared, and the resultant value is going to be distance CA, but CA is 25 minus 10, which is 15 squared, and 10 squared on top of that. So this is CA squared. I just simply write down Pythagoras. Okay. Now what we have the first equation, which relates to the circle, x minus 10 squared and y minus 10 squared equals to radius squared, and the second equation related to Pythagoras. Basically, it's again has common x and y values, so that's why 1 and 2 you need to solve simultaneously. So simultaneous equations. That's the standard way how majority of students actually trying to struggle with this sort of. But if you start doing manually, there are lots of troubleness, because that's quadratic one, and in this case it's not easy to express y through x. Okay, hope GDC and online software can help you and you figure out x and y coordinates. After getting coordinates of D, let's say you've got coordinates x0 and y0 for point D, and obviously you'll get two values because for x and two values for y, because actually there are 2 points, and as you understand, so here is another point, and because of the quadratic equations, so that's why you'll have two parameters, x1 and y1 and x2 y2 as numbers. So you got those values as numbers, okay, as numbers. So after getting those points, you can express the gradients. So the gradient of the segment CD and gradient of the segment CB. But it's gonna be definitely a long way around, okay? Unless you're using something like computer aid, okay? So that's why, so one more time, pause the video, try to compare with what you have, and finally you'll get those gradients, okay? I'm not gonna do that because I don't want to calculate, because definitely it takes a lot of time. So that's why I decided to show you a bit different way that use trigonometry. So this is way 2 that use trigonometry, is based on that, trigonometry. Okay, and which way? We're looking for the gradient, but what stays for the gradient of the segment CD? For example, let's do first with the segment CD. So the gradient of CD is basically equals to the tangent of the angle, which is here. Let's set up as angle for the L1, for the line 1, as L for 1, okay? Let it be the angle itself. So this is tangent of alpha 1. Because it's more than 90 degrees, tangent is going to be negative, and that means that the slope of CD is going to be negative. So I'll help you understand. So that's why if you know angle itself, right, there is the chance that you can calculate tangent of this angle, and that's going to be their gradient of CD. So that's why the primary goal is to find angle alpha. Okay, if you find this angle, you will find angle alpha 1, because if you add them up, you get 180. So the next point, you know the gradient only of the segment. You know the gradient only for the segment of AC. Why? Because you know the both coordinates C and A. So just write down here the coordinates 10 and 10. So that's why if I calculate the gradient, it will indicate the negative, again, the negative gradient for this segment line. And actually, by doing that, you will get to know, for example, this angle. If you just continue this line, just the way down, right? The way down, you will calculate this angle. Okay, let's calculate the angle as the gradient of CA. That's going to be the tangent of, let's say, some angle x. Okay, so that's going to be the tangent of angle x with a minus sign, right? Because the gradient is negative. And angle x is less than 90, okay? So that's why I just put clearly negative tangent. All right, so gradient for CA is basically 25 minus 10 over 10. So that's why it's 15 over 10, which is 1.5. If you press calculator, you'll get that angle x is going to be, let's do that, 10 minus 1 of 1.5, which is going to be around 56.31 to 2 decimal place 4 degrees. Okay, so we've calculated the angle x, it's right here. So that's why we definitely know this angle. So let's set up, it's 90 degrees minus 56.31. And right now we know the top angle that goes from the y-axis up to the yellow line segment, which is bisector. Yes, so this is definitely bisector. So that means those two angles we can set up as better, they're the same. So okay, this angle is going to be 90 minus 56.31. So I'll just do that here. It's going to be 33 and 0.69 degrees. All right, so we know angle, which is the top one, and which represent angle beta plus some another angle. Let's set up gamma. Okay, so this angle is simply represent gamma plus beta. Okay, so that's why in order to find gamma, we need to know beta. How we can get the beta angle? Let's consider triangle CDA that we recently used here before. Okay, it's 90 degrees, and we can figure out beta angle simply from trigonometry. Again, trigonometric ratio in the right angle triangle. So triangle CDA will have hypotenuse CA, which we know, right? And the radius, opposite side, 762. Okay, so that's why we need to know first the distance. So CA is going to be the distance. How much is that? The square root of 15 squared plus 10 squared. Okay, if you calculate that, it's gonna be around 18.03. So 18.03. So again, I just put up to decimal place all the values, and because we know CA, which is here, which is hypotenuse, we can figure out sine of angle beta. So sine of beta actually is opposite side, which is 762. So dA over CA, which is 18.03. And from here we can find beta as sine minus 1 of this fraction, okay? So that's why if I calculate, I'll get around 25 degrees to 2 decimal place. So it's fair enough. You know, I can even write so 25 0 degrees, but okay, you understand that it's 25 up to 2 decimal place. So what we have right now, we have angle beta, which is 25. We know that resultant angle gamma that we're looking for, almost resultant that we're looking for, is going to be 33.69 minus angle beta, which is 25. And if we calculate that, we get angle gamma to be, so 33.69 minus 25, 8.69. But we're looking for this angle, which is angle with an addition with alpha 1 will give you 180. So right now we have gamma, which is right here. So using this small triangle, let's say OC and some another points, we can figure out this angle, which is simply 90 minus angle gamma. And alpha 1 that we're looking alpha 1 that we're looking for is going to be, sorry, have no space, but if I do something, I think that's going to be bad. All right, so I just write here, okay, angle alpha 1 is simply 180 minus 90 degrees and minus angle gamma. I hope you understand how this works. So, all right. And if you calculate that, 180 minus 90 and plus 8.69, you'll get 98.69. So that's gonna be angle alpha. And if you take 10 minus 1 from here, if you take just tangent of this angle, you'll get the final gradient, okay? So I'll figure out that alpha 1 is going to be, so one more time, it's going to be 98.69. And if you use tangent of this angle, alpha 1, you'll get definitely the gradient of your line L1. So that's going to be the gradient for L1, okay? I just move here. So right now, L1, we know that this angle alpha 1, as we calculated, 98.69 degrees. So that's why the gradient for the line 1 is going to be as the tangent of 98.69. And if you calculate that, just one more time, pressing button, obviously, because it's more than 90 degrees, it's going to be negative. So that's why tangent and as well as the gradient will have negative values. So I'll get negative 6.54, okay? And that's why the equation for line 1 should be equal to negative 6.54x plus 25. Okay, so how to be with the line L2? It's pretty straightforward. So remember, we have this, right? And to have angle for the line L2, so we need to know this angle, okay? But this angle as the whole is going to be gamma plus beta and plus beta again. So right now, we know that resultant angle that we're looking for, because knowing this angle, we can figure out angle of the big triangle, yes, of the big triangle, like OC, and some points where you have x-intercept line L2. So that's why it's we need to know this angle, which is y plus 2 beta. If you add them up, just using previous values, gamma is 8.69, and double beta, so we found angle beta, it's 25, so plus 50. So we've got 58.69. And right now, we need to subtract from 90, okay? So 90 minus this angle, will give us the angle that we're looking for. So let's say 90 minus 58.69 is 31.31. And from there, if we take tangent, so if we take the tangent of this angle, 31.31, so we will get 0.608, or just around 0.61. But because the gradient for the line L2 is negative, so right now we found the positive tangent, so which is here, right, of this angle, but we're looking for the angle which is on the opposite side, okay, which is complement. So right now we just put the minus sign, so we're looking actually minus of this tangent, and that's going to be the gradient for the second line. So L2 will have the following equation: negative 0.61x plus 25. So this brilliant way using trigonometry will allow you to save your time. So my explanation, maybe it takes a bit longer because I'll provide all calculations here and just do it step by step so that you can get it. But this saves your time, okay? If you know alternative methods, of course, there's definitely we can use probably derivatives, but the problem is that when students cover circles, it's at year 1, so they don't know derivatives yet, so they're not supposed to use derivatives techniques. So that's why, by the way, it's harder, because you need to differentiate the equation of the circle, which is given you in implicit way. So that's why you need to know how to differentiate implicitly, okay, in order to get the second equation, for example. So that's why either you're gonna use the very first way, that you need to complete equations and solve. The problem is in technical solution here for this particular problem, or you're just gonna use way 2 through trigonometry. It's based on the angles, so that's why I think if you're well in geometry and particularly trigonometry, you can do that. All right, so that's final solution for L1 and for L2. So I circled here. Just compare what you have, and of course subscribe, like this video, and share it with others who struggle with A-level and other math programs like GCC or IB at different levels. So I hope you like that. That was Daniel Dallas, and see you in the next episode.